Section 3, pages 46 through 52, winds. Have you ever flown a kite? Start by unwinding a few meters of string with the kite downwind from you. Have a friend hold the kite overhead. Then, as your friend releases the kite, run directly into the wind. If you're lucky, the kite will start to rise. Once the kite is stable, you can unwind your string to let the wind lift the kite high into the sky. But what exactly is the wind that lifts the kite, and what causes it to blow? Page 47. What is wind? Because air is a fluid, it can move easily from place to place. Differences in air pressure cause the air to move. A wind is the horizontal movement of air from an area of high pressure to an area of low pressure. Winds are caused by differences in air pressure. Most differences in air pressure are caused by the unequal heating of the atmosphere. Convection currents form when an area of Earth's surface is heated by the sun's rays. Air over the heated surface expands and becomes less dense. As the air becomes less dense, its air pressure decreases. If a nearby area is not heated as much, the air above the less heated area will be cooler and denser. The cool, dense air with a higher pressure flows underneath the warm, less dense air. This forces the warm air to rise. Measuring wind. Winds are described by their direction and speed. Wind direction is determined with a wind vane. The wind swings the wind vane so that one end points into the wind. The name of a wind tells you where the wind is coming from. For example, a south wind blows from the south towards the north. A north wind blows to the south. Wind speed can be measured with an anemometer. An anemometer is a 3 or 4 cups mounted at the ends of spokes that spin on an axle. The force of the wind against the cups turns the axle. A meter on the axle shows the wind speed. Wind chill factor. On a warm day, a cool breeze can be refreshing, but during the winter, the same breeze can make you feel uncomfortably cold. The wind blowing over your skin removes the body heat. The stronger the wind and colder you feel. The increased cooling a wind can cause is called the wind chill factor. Thus, a weather report may say, the temperature outside is 20 degrees Fahrenheit, but with the wind speed of 30 miles per hour, the wind chill factor makes it feel like 1 degree above zero. Page 48. Local winds. Have you ever noticed a breeze at the beach on a hot summer day? Even if there is no wind inland, there may be a cool breeze blowing in from the water. This breeze is an example of a local wind. Local winds are winds that blow over short distances. Local winds are caused by the unequal heating of Earth's surface within a small area. Local winds form only when large-scale winds are weak. Sea breeze. Unequal heating often occurs along the shore of a large body of water. It takes more energy to warm up a body of water than it does to warm up an equal area of land. As the sun heats Earth's surface during the day, the land warms up faster than the water. As a result, the air over the land becomes warmer than the air over the water. The warm air expands and rises, creating a low-pressure area. Cool air blows inland from over the water and moves underneath the warm air, causing a sea breeze. A sea breeze or a lake breeze is a local wind that blows from an ocean or a lake. Figure 7 on this page shows an example of a lake breeze. Land breeze. At night, the process is reversed. Land cools more quickly than water, so the air over the land becomes cooler than the air over the water. As the warmer air moves over the water, it expands and rises. Cooler air from the land moves beneath it. The flow of the air from land to a body of water is called a land breeze. And there is an example on the bottom of page 48 of a land breeze as well. Page 49, global winds. Global winds are winds that blow steadily from specific directions over long distances. Like local winds, global winds are created by the unequal heating of Earth's surface. But unlike local winds, global winds occur over a large area. Recall how the sun's radiation strikes Earth. In the middle of the day near the equator, the sun is almost directly overhead. The direct rays from the sun heat Earth's surface intensely. Near the poles, the sun rays strike Earth's surface at a lower angle. The sun's energy is spread out over a larger area, so it heats the surface less. As a result, temperatures near the poles are much lower than they are near the equator. Global convection currents. How do global winds develop? Temperature differences between the equator and the poles produce giant convection currents in the atmosphere. Warm air rises at the equator and cold air sinks at the poles. Therefore, air pressure tends to be lower near the equator and greater near the poles. This difference in pressure causes winds at Earth's surface to blow from the poles towards the equator. Higher in the atmosphere, however, air flows away from the equator toward the poles. Those air movements produce global winds. The Coriolis effect. If Earth did not rotate, global winds would blow in a straight line from the poles towards the equator. Because Earth is rotating, however, global winds do not follow a straight path. As the wind blows, Earth rotates from west to east underneath them, making it seem as if the winds have curved. The way Earth's rotation makes winds curve is called the Coriolis effect. Because of Coriolis effect, global winds in the northern hemisphere gradually turn toward the right. As figure 9 shows, a wind blowing toward the south gradually turns toward the southwest. In the southern hemisphere, winds curve towards the left. Page 50, global wind belts. The Coriolis effect and other factors combine to produce a pattern of calm areas and wind belts around Earth, as shown in figure 11. The calm area includes the doldrums and the horse latitudes. The major global wind belts are the trade winds, the polar easterlies, and the prevailing westerlies. Doldrums. Near the equator, the sun heats the surface strongly. Warm air rises steadily, creating an area of low pressure. Cool air moves into the area but is warmed rapidly and rises before it moves very far. There is very little horizontal motion, so the winds near the equator are very weak. Regions near the equator with little or no wind are called the doldrums. Horse latitudes. Warm air that rises at the equator divides and flows both north and south. Latitude is a distance from the equator measured in degrees. At about 30 degrees north and south latitudes, the air stops moving toward the poles and sinks. In each of these regions, another belt of calm air forms. Hundreds of years ago, sailors becalmed in these waters ran out of food and water for their horses and had to throw their horses overboard. Because of this, the latitudes 30 degrees north and south of the equator became called the horse latitudes. Trade winds. When the cold air over the horse latitude sinks, it produces a region of high pressure. This high pressure causes surface winds to blow both towards the equator and away from it. The winds that blow toward the equator are turned west by the Coriolis effect. As a result, winds in the northern hemisphere between 30 degrees north latitude and the equator generally blow from the northeast. In the southern hemisphere between 30 degrees south latitude and the equator, the winds blow from the southeast. For hundreds of years, sailors relied on these winds to move ships carrying valuable cargoes from Europe to the West Indies and South America. As a result, these steady easterly winds are called the trade winds. Prevailing westerlies. In the mid-latitudes between 30 degrees and 60 degrees north and south, winds that blow towards the poles are turned toward the east by the Coriolis effect. Because they blow from the west to the east, they are called prevailing westerlies. The prevailing westerlies blow generally from the southwest in the north latitudes and from the northwest in the south latitudes. The prevailing westerlies play an important part in the weather of the United States. On page 51 is a diagram that will have each one of these labeled as far as the doldrums, the horse latitudes, trade winds, and prevailing westerlies. This would be a useful tool to understand what I just read. On page 52, polar easterlies. Cold air near the poles sinks and flows back towards lower latitudes. The Coriolis effect shifts these polar winds to the west, producing the polar easterlies. The polar easterlies meet the prevailing westerlies at about 60 degrees north and 60 degrees south latitudes, along a region called the polar front. The mixing of warm and cold air along the polar front has a major effect on weather in the United States. Jet streams. About 10 kilometers above Earth's surface are bands of high-speed winds called jet streams. These winds are hundreds of kilometers wide, but only a few kilometers deep. Jet streams generally blow from west to east at speeds of 200 to 400 kilometers per hour. As shown in Figure 12, as jet streams travel around Earth, they wander north and south along a wavy path. You did have an assignment that was given today in science, and it was the Section 3 assessment questions. If you could please refer to Mrs. Turnow's Google Classroom calendar, it will have the specifics about what questions and which A, B, and C you are required to answer. Thank you.